So, supervised learning. Yesterday we have talked about the decision tree and random forest. Decision tree is a single tree model. Random forest is a multi-tree model or ensemble method using a bagging method. Now, today, supervised learning. Within supervised learning, ensemble methods multi-tree model, boosting, and the algorithm is gradient boosting GBM. Supervised learning, ensemble methods, multi-tree model, boosting method. Yesterday we talked about the bagging method. Today we are talking about the boosting method. And the popular algorithm is gradient boosting machine, GBM. So, gradient boosting machines, GBMs, are developed. GBM focus on weak learners or wrong predictions. And these class of algorithms are developed to increase the accuracy and reduce the error of models. Gradient boosting machine, GBMs, they have been exclusively developed to work on weak learners or wrong predictions. They focus mostly on weak learners or wrong predictions. Weak learners or wrong predictions are assigned more weightage in the model fitting. So how do they focus on the weak learners or wrong predictions? By assigning more weightage during the model building process or the model fitting process. So gradient boosting machines were exclusively developed to increase the accuracy of the models, to make the weak learners move towards the right learner or right prediction. So how do they do it? By assigning more weightage to these weak learners in the model building process. Observations that are classified correctly are given less weightage, or sometimes they are not considered into the sample itself. But those observations which are wrongly classified are given more priority and more precedence in the sampling process. Here also, step 1, define the number of trees to be built. N dot tree is equal to 1000. Define the number of trees to be built. Step 2, create sample 1 with randomly selected 65% of observations or rows and square root of number of variables or columns, sample 1 will be created. Step 3. Build a decision tree for sample 1 and also predict. Build a decision tree for sample 1 and also predict. Step 4. Identify the wrong predictions and move them to sample 2. Move them to sample 2. Step 5. Replenish the sample. That means get more observations and fill the data quantity. And complete sample 2. Step 6. Build a decision tree for sample 2 and predict. Step 7. Identify wrong predictions and move them to sample 3. Continue process. So this process will continue till you get the 1000 trees. So here the most important thing you need to understand is each sample is dependent on previous trees. The next sample is dependent on previous trees, and the wrong predictions are boosted by assigning more weightage. So GBM follow sequential building of trees. Sequential building of trees. Sequential. Whereas random forest is parallel. Here it is sequential. Until tree 1 is completed, you will not get sample for tree 2. So sequential building of trees. One by one, the tree will be built. So boostings are devised to focus on wrong predictions. They tend to have higher accuracies in the data science. Now there are variants like XGBoost, Light GBM, XGBoost. So if you look at the competition sites, competitions and hackathons, these algorithms dominate. Extreme gradient boosting, light gradient boosting, cat boosting, categorical boosting, these set of algorithms or boosting algorithms, they tend to have very, very high accuracies because they are exclusively developed to work on wrong predictions. And like normal decision tree only, each tree will be just your normal decision tree only. Splitting methods are your Gini entropy and information gain. They follow the same process, like how your single tree model has. Same process will be implemented in here also. A full decision tree will be built. Okay. So install.packages GPM. Hmm. If install.package is not working, go to packages and click on install and find the version that is suitable to your version and then install. Yeah. Data is strong. Environment is imported. You didn't save it properly. That's what once you close it, you have to wait till it saves. Re-import the data. Run these two commands and then you can select all this and then run them. Import commands run separately. Then now. Okay. HR GBM is equal to GBM as dot factor is underscore promoted tilde dot comma data is equal to HR train BF comma distribution is equal to Bernoulli. Distribution is equal to Bernoulli, right? Our binary Bernoulli is binomial distribution. Our dependent variable is binary. Bernoulli is binomial distribution, comma n dot trees is equal to 1000, comma CV dot folds is equal to 3. CV dot folds is equal to 3. Cross validation folds. Session aborted. Wait a second. I think 1000 trees it's not able to take. Session is aborted. The problem with GBM. Data is lost. Huh? No, data is there. Sorry. Library GBM. 1 second. Huh? Don't run. This session is getting aborted. 1000 trees, it's not able to build. CV is not working. So we will remove the CV. CV dot folds to number of trees 500. Let us see if this works. No, it's not working. You're also getting about from the session about. Okay. Then we will do one thing. We'll remove CV dot folds. We will done with the. We'll go with the direct method. This is what happens if your computing power is not enough. It is not doesn't have enough CPU power to run it. So that is why it is getting failed. Yeah, it is recording. So remove CV dot folds. We use method is equal to OOB. Yeah, it ran. Increase it to 1000 trees. Test dot iter is equal to GBM Hello. Yes. Yeah. Tell me, what is the requirement? Okay. That would be part-time, sorry, full-time is not possible as of now. Part-time would be the better option. That depends on what type of trainings you are looking at. Because I have other commitments also. Yeah, freelancer. So I have tied with some tech firms like Simply Learn, Imaticus, and I'm also visiting professor in 3 universities. Yeah, go ahead, please. Yeah, I have clients HSBC, Society Generally, State Bank of India, Wells Fargo. I have done a lot of corporate trainings. Hmm. Yeah, tell me. Your voice is breaking. So we are not able to run it with the GBM package, right? So it says no infinite OOB is available. You are also getting the same error? Yeah, hello? It depends on the schedules. Right now, I have some schedules going on till August. So days have to be. Yeah, it will see schedules depends. What program, how many days, how many hours they want. Based on that, we will schedule it. Hmm. What project they'll provide? Okay. Hmm. That means I have to give daily commitment. Do I have to give a daily commitment? Okay. Yeah, if it is 2 days in a week or it like that, we can adjust. That's not a problem. That goes up my all assignments put together goes up to around 20 to 25 lakh. All the assignments put together. Hmm. See, this is hourly basis. Like if you are looking at hourly basis, it depends on the training module and what you want, the level. It starts from say from basic statistics. I take per hour 3,000 rupees. 3,000 rupees per hour for basic statistics and all. For advanced modules, it will be 5,000 to 7,500 per hour. Yeah. Okay. So we will go to carrot package. Okay. So this GBM is giving us error, right? We are not able to run anything in GBM. The methods are not working. Method is equal to OV is not working. Method is equal to CV anyway, it is not running. If method is equal to test and all also are not working. So we'll go with carrot. Library carrot. We don't have enough system cores to run the algorithm. It is aborting the session means CPU is not able to handle the data. Control is equal to train control. So we have to define our train control in GBM. Method is equal to CV. Comma repeats is equal to 5. CV is cross validation. Okay, not repeats, number. Number is equal to 5. HR GBM is equal to train as dot factor is underscore promoted tilde dot comma data is equal to HR train DF comma method is equal to GBM comma train control is equal to fit CTRL Unexpected error means bracket problem. Check the brackets. Summary HRGBM. So summary HRGBM is giving us variable importance. Print HRGBM. So stochastic gradient boosting, no pre-processing, 5-fold cross validation. Each sample size is this. Interaction depth 1, 2, 3, entries 50, accuracy kappa. So 92, 93, tuning shrinkage was the final value. So used for the model were n dot trace is equal to 150, interaction depth is 3, n dot mean observation node is equal to 10. Okay. HRGBM dollar model info it is going to the okay. Now GBM predict is equal to predict HRGBM comma HR train DF comma type is equal to class. So type is equal to prob. Table actual is equal to HR train DF dollar is underscore promoted comma predicted is equal to EBM predict greater than 0.50. Okay, we got two probabilities. Okay. We can't use this, so we have to convert it. GBM predict is equal to if else GBM predict $0 greater than equal to 0.50 comma 1 comma 0. table actual is equal to HR train df dollar is underscore promoted, comma, predicted is equal to GBM predict. Oh, sorry, we have reversed it. This must be 0, 1. Okay, so the confusion matrix is 50,077 plus 1393 divided by 50,077 plus 63 plus 3275 plus 1393 with an accuracy of 93.90. Problem corrected? So by default, it is taking 150 trees. By default, it is taking 150 trees. Lot HR GBM So max depth at 3 is the tree it is taking, is around 93.50, it is taking the highest value. So if you want to predict, GBM test predict is equal to predict HR GBM, comma, HR test DF, comma, type is equal to probability. Type is equal to probability. Then GBM test predict is equal to if else Huh? What do you mean? 0, 1, not 1, 0. Change it to 0, 1. Greater than equal to 0.50, comma 0, 1. You have to run the type probability again. Get the probability again and then do it. I'll come 1 second. EBM test predict $0 greater than 0.50, comma 0, comma 1. Write.csv EBM test predict EBM.csv. Corrected it? No. You have to run the probability again. That's minor difference will come because there is random sampling. Minor difference will be because of random sampling. A random sampling, you know, just like random. So your sample will be different, mine will be different. So marginal difference will be there, but overall accuracy will be similar. We want more, and weight is equal to you have to give all now. You guys submitted, anybody submitted? Score improvement is there? No submission. See, my code also changed slightly. Again, 3.3, 30, 60. So Carrot has this ability of all the models. You can see Carrot has a lot of models. So Carrot, so a list of available models in trained in Carrot, you can see many models are available. So these are all available there. XGBoost classification, Let us see. Extreme gradient boosting we have. Okay, XGB dot XGB linear. XGB dot XGB linear. XGB tree is also there. So there are many models, hundreds of models are available within Carrot package. You can see here, right? Method is equal to, I think even KN RF is also there, random forest. See, oblique random forest, parallel random forest, random ferns, simple random forest. Method is equal to RF. You can also run KNN is also there. KNN reg and KNN nearest neighbors. So all models are available. So there are some close to 300 models available. Neighbors, neural networks, everything is available in Carrot library. So when you go to industry, Carrot is a very important library you need to understand, because you have the same problem. Memory error problems will come for large scale data. That time we tend to use Carrot. There is one more library called H2O. H2O is also a library which is there for running large scale data in R. H2O in R is another library which you will be using. H2O.ai. Some companies have invested in this H2O library also. This runs for large scale data projects, H2O, deep learning and all. So H2O will work during deep learning. When we are doing deep learning models, that time we can use H2O for Keras and all. So H2O is also very interesting library wherein we can do a lot of analysis. This requires a little bit of Java implementation. So you have this all the models. If you are not able to run random forest on your native machine, you can run it on random forest, because random forest uses, H2O uses Java virtual machines. It uses Java virtual machines. So your model will not have any problem in running the large scale. So H2O is another library we'll be working upon. Now on our current data, let us do XGB tree, XGBoost tree. Oh, we have not implemented in regression, right? Let us implement it in regression. BigMart ARP, BigMart sales. Open the BigMart sales, gradient boosting. So library Carrot. Okay. So we will go with the same. Control is equal to train control. Method is equal to CV. Number is equal to 5. Okay. Cross validation with 5 times. 5 times cross validation. Bigmart GBM is equal to train open bracket item underscore outlet underscore sales filled dot comma data is equal to Bigmart train DF comma method is equal to GBM comma we have to specify the metric also. Metric is equal to RMSE because by default the metric is accuracy. Train control is equal to fit CTRL. Summary Bigmart GBM. So again, we got some variables which are important. Some of them are not important. Print Bigmart GBM. So Bigmart GBM, you can see the model. Stochastic gradient boostings, no pre-processing, cross-validated 5-fold, RMSE, R squared. You can see here, highest RMS, lowest RMSE is 1089, highest R square is 59.2, entries is 100, interaction depth is 3, shrinkage is 0.1, minimum observed notations is equal to 10. GBM test predict is equal to predict Bigmart GBM, comma, Bigmart test DF, comma, type is equal to raw. Type is equal to raw will give you vector of prices. Rate of a vector of sales. You got the sales. Write.csv GBM test predict GBM.csv. Gradient boosting as regression. So lowest RMS is somewhere around 1159. I think you can increase the iterations. Any chance in increasing the score? So negative values have come out, GBM. Oh, you got negative values. So sales cannot be negative. Okay. So this is the process of running gradient boosting machine in our tree. If you want to run extreme gradient boosting, just change it to XGB tree. We can just change this to XGB tree. So XGBoost. So extreme gradient boosting. This is a very popular algorithm. So fit control will keep it same. So we will not, okay, no need of copying fit control because fit control will keep it same. So Big Mart XG boost is equal to, you can copy the same command from top, Control C, Control V. Method is equal to XGB tree. So we have to install the library also. Okay, yes. I forgot, we have to install XGBoost. So summary, Big Mart XGBoost print Big Mart XGBoost. So we got the print output. Plot Big Mart XGBoost. You can see here the plots with multiple sample size eta and various RMSE cross validations. 80% sample, 20% training. 80% train, 20% test. Eta is the learning rate. So then what we can do is XGBoost test predict is equal to predict Big Mart XGBoost, comma Big Mart test df, comma type is equal to raw. At XGBoost test predict. Write dot CSV XGBoost test predict XGB.CSV. XGB.CSV, do we have any negative values? Let me check once. Yeah, we have negative values. So we can't submit the XGBoost also because we have negative values. So this is the process of running the XGBoost, extreme gradient boosting in R. HR analytics score improved for GBM? No, no improvement. If you are done with this, run XGBoost in HR analytics also. Run XGBoost in HR analytics also. That's all. Because it is an error. See, that's a duplication error. Number of trees is ignored. Iteration rate equal to you say warning. Right? It keeps on coming because 150 times it comes. Trees is only 150, right? Like how we had earlier running 1 to 1 time 20, 30, 40, same thing is running. So don't worry about it. What it says is entry limit is replaced with the iteration number. Right? For every 10 iterations, it will do the same warning. Earlier also it ran like that, 10, 20, 30. Same thing it is done. So that iteration underscore range you have to give instead of entries. That is what it is warning. All right, you ran it on HR Analytics. See if your score improves. All right, it ran. So XGBoost on HR Analytics also. Any improvement in score? No improvement. It has improved. Huh? It's running. Run it on HR Analytics also. Okay, run it. HR Analytics. So we'll take a break and then we'll come back. All right. Let's take a break.